Okay, so guys, from the last decade, this is what we did. Okay, so remember we jumped around. We started out with matrices, linear programming, data analysis. Those were three just real separate topics. And then once we got into quadratics, that was sort of where the heart of Algebra 2 is. Okay, we're going to continue there. So we're going to talk about properties of exponents and radicals, square roots, fourth roots, cube roots. Then we'll move into probably our biggest unit is polynomials. Okay, very important unit getting ready for pre-calculus. Rational expressions, there's a lot of algebraic manipulation when you have fractions involved with your algebraic expressions. And then the big unit, probably the second biggest unit, conic sections, graphing these parabolas that go sideways, hyperbolas, ellipses, circles. So a lot of graphing happens in this last section. So I think of this as sort of the harder topic, but by the time we get there, you guys will have so much more mathematical maturity under your belt from all we've done through the year. And so I'm always surprised that kids are handling a lot more complexity by the time we get there. So anyway, it'll be good and we will enjoy the journey as we go. So let's talk about properties of exponents. So this is going to be a review of properties of exponents. You should have seen this in a past life, in a past math class, but we want to talk about different properties of exponents, okay? What you need to think about when you think about exponents, it's really just repeated multiplication. So for example, 2 cubed, okay? You know that 2 cubed is what? It is 8. All it really means is this is repeated multiplication. This is a 2 multiplied by itself how many times? 3 times. That just means 2 multiplied by itself 3 times. So this is 2 times 2 times 2, which is 8. Okay? So that's all exponents are, repeated multiplication. Okay? So if I were to have something like 2 to the second times 2 cubed, okay? This is 2 multiplied how many times? 2. This is 2 multiplied how many times? 3. How many total times would it be multiplied? 5. So this is 2 to the 2 plus 3, or 2 to the 5th, or 32. Okay? So the property of exponents here, if I have a product of powers, okay, so if I've got different things raised to powers, and I multiply this, a to the m times a to the n, that's a to the m plus n. I just add the exponents. So in this case, 5 cubed times 5 to the negative 1. This is going to be 5 to the 3 plus negative 1. What's 3 plus negative 1? 2. This is 5 squared. What's 5 squared? That's 25. Okay? So the power of a product. Okay? So if I've got something raised to a power and then I raise that to a power, what happens to those exponents? They're multiplied. What is going on here is I've got something like if I had 2 cubed squared, okay? What this means is this squared means I've got 2 cubed times 2 cubed, okay? And this means I've got 2 multiplied how many times? 3, and this is 3. So if I multiply it 3 times and 3 times, how many times is that? 6 times, okay? So this is what, 64. So it's 2 to the 3 times 2, okay? So when I have a to the m times to the nth power, those exponents are multiplied. This is a to the mn. So this is 3 to what power? 6. So 3 to the 6, and I don't know that one off the top of my head. 3 to the 4th is 81, so it's 81 times 6. So I'll just leave it 3 to the 6. The power of a product, okay? So in this case, if I've got things that are multiplied, AB raised to the m power, that's the same as a to the m times b to the m. So in this case, this is 6 to the 4th power, but I can also write this as 2 to the 4th times 3 to the 4th. What is 2 to the 4th? I'm going to go with 16. What's 3 to the 4th? 3 times 3 times 3 times 3, 81. So 16 times 81, somebody with a calculator. What is 16 times 81? 1296. Okay, I will trust you on that one. And then if I have the quotient of powers, a to the m divided by a to the n, and what happens with those exponents is they are subtracted. Okay, so a to the m divided by a to the m is a to the m minus n. Okay, so in this case, this is 6 to the minus 3 minus what? Minus negative 6. What does it mean to say minus negative 6? What is that? That's plus 6. So this is 6. This is 6 to the minus 3 plus 6. That's 6 cubed. Okay, which is, what is 6 times 36? Calculator. I'm gonna have to turn my calculator on. Okay. Equal 216. Okay. There we go. The power of a quotient. When I've got things that are divided, raised to the power, it just makes sense here. You can distribute that exponent. A over b to the mth power is a to the m over b to the m. So in this case, this is 4 squared over 7 squared, which is what? 16 over 49. Now, negative exponents. They are not to be feared, okay? If you think about raising something to an exponent, like 7 squared, that's 7 times 7. That's repeated multiplication. When I think of 7 to the negative 2, what's the opposite of multiplication? Division. So 7 to the negative 2 is not repeated multiplication, it's repeated division. So this is really 1 over 7 squared, which is 1 over 7 times 1 over 7, which is what? 1 over 49. Okay. So with negative exponents, it's repeated division. The way we handle negative exponents is when I see something like 7 to the negative 2, think of it like this. Is that negative exponent in the top of my fraction or the bottom of the fraction? It's in the top of the fraction. It will become positive when I move it where? To the bottom. So all you have to do with the negative exponents is write this as 1 over 7 squared. To make that negative exponent positive, wherever I find it, I move it to where it's not. Okay, so if I find it in the top of the fraction, it becomes a positive exponent when I move it to the bottom of the fraction. What if I found the negative exponent in the bottom of a fraction? It would become positive when I move it where? To the top. Okay, so this one is just 1 over 49. Okay, and zero exponent. When you raise something to the 0 power, what do you get? No, 1. Okay, anything to the 0 power is 1 with the exception of one situation. This is undefined. So 0 to the 0 power is undefined. But anything else to the 0 power, don't waste a lot of time with this one. It is just 1. Okay? So any number other than 0 raised to the 0 power is going to be 1. Okay, so this should be ringing bells in your head of things you've seen before, is that right? Okay. I'm not getting warm fuzzies yet, but you know, it's early. So we'll get there. So let's do some work with this. So the way it works, everything we went through, I'm not going to quiz you what's the product of powers rule, what's the quotient of powers used. I don't quiz you on what those rules are. You just sort of have to know how to work through these. Okay, so here I've got two things multiplied. What do I do with the exponents here? I add them together. So this is x to the 2 plus 3 power. What is that? That is x to the 5th. Okay, using property of exponents, when I got two things multiplied, raised to different exponents, I just add those exponents together. Okay, in this case, I've got something raised to a power and then again raised to a power. What do I do with those exponents? I multiply. So this is going to be x to what power? X to the 2 times 3, which is x to the 6. Okay, look at the next one. What is being cubed? Both of these, the x and the y. So this can be written as what? x cubed, y cubed. Okay? See, this is all easy, right? X to the fifth divided by x to the third power. What do I do with exponents when I have a quotient? I subtract them. So this is going to be x to what? It's 5 what? X to the 5 minus 3, which is x squared. What if this had been, oh, and there's, I was about to go freestyle, but that is the next question. X to the third over x to the fifth. So what do I do here? This is what? This is x to the what? 3 minus 5, which is x to the negative 2. We really don't like to leave negative exponents. What is x to the negative 2? 1 over x to the positive 2. Okay? So this answer is 1 over x squared. Now, another way that people will do this problem is, which of the exponents is bigger, the 5 or the 3? Yeah, so I could write this as 1 over x to the 5 minus 3. So instead of writing 3 minus 5 from the top, I can do my subtraction from the bottom. So 1 over x to the 5 minus 3. So this becomes what? 1 over x squared, same answer, okay? So there are two different ways. In most of these problems, there are going to be multiple paths to getting to the right answer. As long as you are not breaking any of the laws of exponents, you're going to get where you need to go, okay? X over y to the fourth, what is that? Yeah, this is x to the fourth divided by y to the fourth, okay? See how easy to do is you've got to be able to talk to yourself, or however you do this, and just talk through what really needs to happen here. Okay, so I've got 2 times x to the negative 1 y squared over x squared y to the negative third. I want to simplify this. I don't want any negative exponents. Okay, so what's going on here? What is being squared? Yeah, x to the negative 1y is all being squared. So I could rewrite this as 2. And then what happens to exponents when I've got something raised to a power and then raised to another power? What do I do with those exponents? Multiply them. So this is going to be x to what power? Yeah, x to the negative 2, because I multiply the negative 1 and the 2. And then y to what power? Squared over x squared y to the negative third. Okay. Now, a really good way to miss this problem and lose points is to cancel out the x's. What is wrong with that? Are those the same numbers? No, they're not. Okay, so forget that I even put that in your psyche that that was a possibility. Okay, so now I've got to simplify this. I can just write this as 2. Okay, when I have quotients, what do I do with the exponents? Add, subtract, or multiply? I subtract them. Okay, so this is going to be x to the negative 2. And what do I do with that exponent? Yeah, minus 2. And then y to what power? 2 what? Minus negative 3. Okay, so what do I get here? This is 2x to what power? Negative 4. And what is 2 minus negative 3? Yeah, y to the fifth. Okay, I want my answer to have no negative exponents. So what would be my final step here? Yeah, 2y to the fifth divided by x to the fourth. Okay, this is sort of as hard as it gets. Okay, are there questions over what I did there? Okay, so what do? We had several things going on here. I had a product raised to a power, so I had to multiply the exponents. I had a quotient, so I had to subtract the exponents. I had a negative exponent in my final answer. I had to make that a positive exponent. So of those properties on that first page, we used about 3 of them here to get to this final answer. So the first step is just Okay, if I've got something squared here, then that applies to everything in here. So I multiply these exponents. Then if I've got like terms and a quotient, it's going to be this exponent minus this one, this minus this. Got to be really good with your arithmetic of these minus signs. One of those can trip you up, okay? So I'm still trying to read the room. Am I going too slow, this too easy, or what is this? This is about right? Okay. Now, look at this one. Looks pretty complicated, but this one gets easy in a hurry. Yeah, what is that big thing, ugly thing raised to the 0 power is what? Is 1, okay? So don't spend a whole lot of time working on this. This expression right here that I'm going to highlight, that's just an ugly way of writing the number 1. I've got something raised to the 0 power. So this turns into 2x to the negative 2 over x. Okay, does that look a whole lot easier? So what is raised to the negative 2 power? What? 2x. Both of those things are raised to the negative 2. So let's distribute it out. This is 2 to the negative 2, x to the negative 2 over x. Now what do I do to simplify that? Yeah, here are where I can do a couple of things. If you notice, what I can do is I can say, okay, this is going to be 2 to the negative 2, x to the negative 2 minus 1. I can subtract the exponents because this is x to the 1, okay? That's one way of doing it, and this gives me what? This is 2 to the negative 2, x to the negative 3, negative 2 minus 1, okay? What's 2? How do I write 2 to the negative 2? What is that? What's 2 to the negative 2? That's 1 over 2 squared, and then x to the negative 3 is just x cubed on the bottom of that fraction. So what is this final answer? 1 over 4 x cubed. It was a negative exponent on the top of the fraction. A negative exponent on the top of your fraction only becomes a positive exponent when you move to the bottom of the fraction. Okay? Now, another way I could have done this is like, what if I decided to move this x to the negative 2? Let me move it to the bottom right now. Okay? So this is going to be 2 to the negative 2 over x squared times x. Just move that x to the negative 2 at the very beginning. Okay? Then what do I get? This is 2 to the negative 2 over x cubed. What's 2 to the negative 2? It's 1 over 2 squared. So this is 1 over 2 squared x cubed, which is 1 over 4 x cubed. Okay? So I can do all of my work and at the very end move things from negative exponents, or I could move it earlier in the phrase. It doesn't matter. So there are different routes of getting to this answer as long as you are obeying the rules and the laws of exponents. So let's look at this one. What is being cubed? Basically everything inside that parentheses is being cubed. Okay? So if I cube everything, I'm going to have a to what power? A to the 6, b to the what? Negative 3. Okay, what is 2 cubed? 2 cubed? 8. What is a cubed cubed? A to what power? A to the 9th. B squared cubed is b to the what? 6. Okay. And now what do I do? Yeah, so this is going to be a to the 6 what? What do I do? 6 minus 9. B to the negative 3 minus what? 6 over 8. What is a to the 6 minus 9? Yeah, so this is a to the negative 3, b to the what? Negative 9 over 8. And what do I do to get rid of those negative exponents? Yeah, I move them from the numerator to the denominator. So this final answer is 1 over 8, a cubed, b ninth. And there we are. And wasn't that fun? So it's a great way to start 2020, right? With exponents. Okay, what about the next one? What's different here? I got quotients, I've got products, I got powers. We got everything, every rule on that first page is coming into play in this next one, okay? What is raised to the negative 2 power? Yeah, everything in that parenthesis. So when I simplify this is going to be c to what power? Negative 2 over, yeah, what happens when you do, what do you do with these exponents? What is negative 4 times negative 2? Positive 8. Okay, so I've got c to the negative 2 over d to the 8th times d squared over c. Okay, so this is going to be c to what power? Negative 2, what? What's the exponent here? Yeah, so it's negative 2 minus 1. And then d to the what power? 2 what? Plus 8 minus 8 times 8 what? D to the what? 2 minus 8? So what is c to the negative 2 minus 1? That's c to what power? Yeah, c to the negative 3. And d to what power? Negative 6. And so this final answer is going to be what? Yeah, 1 over c cubed d to the 6. Now here's the other thing that I'm not going to test you on memorization. That in the course of working with exponents, the more of these things that you know, the better off you are. I don't walk around with 2 to the 10th as 20, 10, 24. This one I don't know. But I'm, with the 2's, I'm pretty good, without thinking on what those guys are. Certainly with 3's, if I can, those first things. So when you see something 3 cubed, you don't have to rely on your calculator to go 3 times 3 times 3. The more you work with this, you'll know 3 cubed is 27. 3 to the 4th is 81. Yeah, I struggle with some of these off the top of my head. I don't certainly know that one, but you will have a calculator. You can't use your TI on some of this, but you could certainly have a calculator to work on this. But the more of these powers that you know, it just helps you quickly, especially the ones that are like this, something to the second power or the third power. It'll save you time knowing that 5 cubed is 125, not having to look that up every time. So that being in mind, let's evaluate some things with properties of exponents, okay? So in the first one, what is being squared? 2. Okay, so 2 squared means a 2 is being multiplied by itself how many times? Twice. What is 2 squared? 4. See how easy this is? So there we go. Okay. Now in the next one, what is being squared? Negative 2. So this is negative 2 times negative 2, which is 4. So I got the same answer there. Okay. Now in the next one, what is being squared? 2. Okay. There's a difference between this one and this one. This is what it looks like for negative 2 to be squared. What is being squared? So when you look at an exponent, the exponent applies to whatever is immediately to the left. Okay. Immediately to the left of this exponent is the number negative 2. Immediately to the left of this exponent is the number 2, but it has what stuck in front of it? A negative. So this is the negative of 2 squared, which is what? This is negative 4, okay? So this is one that tricks people up. So know the difference between this exponent applies to what's immediately to the left. So this is the negative of 2 squared, okay? What is 2 to the negative 2? Is 2 to the negative 2 a positive number or a negative number? It's positive. It's a positive number. So how do I handle this? This is a negative exponent found in the top of a fraction. How do you handle a negative exponent found in the top of a fraction? Yeah, it becomes positive where? In the bottom of the fraction. This is 1 over 2 squared. What's 1 over 2 squared? That is 1/4. Negative 2 to the negative 2 power, okay? So, what do I do with the negative exponent? This negative exponent is found in what part of the fraction in this one? The top of the fraction, so it becomes positive when I move it to the bottom. So this is 1 over negative 2 squared. What is being squared? Negative 2. What is negative 2 squared? Yeah, so this answer is 1/4, okay? Now in the next one, what is being raised to the negative 2 power? 2. Why is it not a negative 2 being raised? Yeah, so the exponent only deals with what's immediately to the left. So I can rewrite this. This is negative 1 over 2 squared. What is 2 squared? 4. So this is, what's the answer here? Is negative 1/4. Okay. So notice the difference between these two expressions. If the negative number is being squared, you're going to have a parentheses. This is the negative of 2 to the negative 2. Okay. Now in the next one, what is being raised to the negative 2 power? 1/2. Now you got a couple ways of doing this. You could treat this as 1 to the negative 2 over 2 to the negative 2. Okay. And then what do I do? How do I make that exponent positive? Yeah. So I can, this becomes what? 2 squared over 1 squared. What's 2 squared? 4. 1 squared is 1. So this is just 4. So what you can do, like I said, I distributed the exponent, but the other thing that you can do when you have a fraction is you can just flip it immediately. So what I could do with this is just say, this is going to be 2 over 1 squared, okay? So if I look at 1 over 2 to the negative 2 is the same as 2 over 1 squared, and so what is this number? That is 4. I get the same answer, okay? So let's look at this one. What is being raised to the negative 2 power here? 1/2. Is the negative being raised to that power? No, okay? So I can just rewrite this one. This is the negative of, if I write this as 2 over 1, what power is that raised to? When I flip it, what happens? Yeah, this becomes 2 over 1 squared, okay? So this is just negative 4, okay? Another way of doing this is just to say, okay, this is the negative of 1 to the negative 2 over 2 to the negative 2, which is negative of 2 squared over 1 squared, which is negative 4, okay? How much more? This is it, and we are done. Let's take a little bit of a break. So let's evaluate these numerical expressions using the properties of exponents, okay? So what do I need to do here, okay? What is being cubed? Everything in the parentheses is being cubed, okay? So I've got negative 3 squared, and that has to be raised to what power? I mean, that part's raised to the third power, times 5 to the third power, okay? So how do I handle this? Okay. These exponents are not going to be added. They have to be what? multiplied, okay? Because I've got something raised to a power and then raised to a power. So to think of this, I've got negative, so this is negative of 3 squared to the third power. So think about it, this is what this is. This is negative 1 times 3 squared. This is what I got going on here. I've got a negative 1 times 3 squared. All of that is cubed, okay? So what is negative 1 cubed? Let's just write it down. I've got negative 1 cubed. 3 to what power? The 6, okay? And 5 to the third. What is negative 1 cubed? Negative 1. So this is just negative of 3 to the 6, 5 cubed. Okay? Pardon me? Okay, so some people are saying, why didn't I just write negative 3 to the 6? Is that what you're saying? Okay. Negative 3 to the 6 times 5 cubed. Okay. That would work. Okay. Where that would fall apart if I had this. Negative 3 squared times 5 squared. Okay. Because what would you say this is? Okay, so that's what people are thinking this might be. Okay. So what this is I got a negative 1 times 3 squared times 5, all of that being squared. So so that's what you're losing. So I got negative 1 squared. I've got 3 to the 4th, 5 squared. So this is 3 to the 4th, 5 squared. It's positive, okay? Yeah, so here I've got this negative is being squared. Here, this negative is being cubed. When a negative is being cubed, you're going to end up with a negative, okay? Pardon me? What I'm saying is, if you just take this negative straight to your answer, it works when I've got an odd exponent, but it doesn't with an even, okay? Okay, now this guy. I've got this fraction all raised to the negative 2 power. What would this fraction be if it were not raised to the negative 2? It would be what?
3 squared over 1/4.
Yeah, 3 over. So this is what it would be raised to the second power. Okay. What is 3 squared? 9. So this is 9 squared over 1 to the what, 8th? What's 1 to the 8th? 1. This answer is what? It's just 81. Okay. Okay, this guy. I've got something raised to exponents and then raised to exponent. What happens to these exponents? They are what? Yeah, so this is 4 to the negative 2 times what? Negative 2. And 3 to the what? Yeah, so this is what? 4 to the 4th. 3 to the negative 4th, right? Which is 4 to the 4th over 3 to the 4th. So 4 to the 4th is, what's 16 times 16? 256. So this is 256 over 81. Okay, what about the next one? What do I do? Yeah, several things. I could distribute the exponent, or I could flip it now. There's several ways of getting there, okay? So why don't we write it like this? We could write this as the negative of 3 to the negative 2 over 2 squared squared. Mm-hmm. So this is negative of 3 to what power? Negative 4, and 2 to what power? 4th. So this is negative of what? 2 to the 4th, 3 to the 4th. So negative 1 over 16 times 81. Okay. And what is 16 times 81? Yeah. -1 over 1296. Okay. Now, another way of doing this, I could have just distributed, this is what? Negative of 2 to the 2 times -2, -4. 3 to the 4th. So the -2 times -2. So I get to the same answer, -1 over 2 to the 4th, 3 to the 4th. So there are different routes to getting to the same answer, just obeying the properties of exponents.
Does the exponent over the 3 in the very beginning when you flipped it, does that -2 not switch to a positive 2 when you flip it?
Right here?
Yeah.
No, so yeah, you're right. Oh, did I do that wrong? No. So here's what I was taking care of this exponent. So to take care of this negative exponent, I flipped it, okay? I could have, if I was going to get rid of that negative exponent, I would have had to move it to the bottom, which I eventually did, okay?
So you could have flipped it back.
Yeah, so I could have gone from here, you could have gone to, there, okay, which gets you to the same answer. So there, like I said, there are different paths you can take on the journey here. As long as you are not making up your own rules of exponents, you're good, okay? Just use the ones that we have, okay?